what is the voltage drop across the 75 ohm resistor and the total current supplied by the battery? Okay, so the current one's the easy one, so we'll do that first. And we actually use it for part A, so it just makes sense to do that first. To find the current, since we're given the total voltage and we can find the total resistance, we're going to use V equals IR, and we're going to solve for current. So I equals V over R. Now, using that, we can say, let's see, first we have to find the resistance, right? The total resistance. Now, this is a combination of a series and parallel circuit. When I do these, I always say, treat it like a series, except when it's parallel, or something like that. I don't know. If that's just too complicated, just, what you have to do is group each resistor if it's parallel together, and you use the parallel circuit resistance formula to find the total resistance. And then once you do that, you add the series parts together. And if there were, well, yeah, that's the basic concept. So the total resistance is, the resistance of 1 plus, now I just, I know how to do the parallel resist, or what the total of the parallel resistance would be from this, but if you were solving for it yourself, you solve for that first, the total resistance of the parallel portion of the circuit. Using that, you say the total resistance equals 25 plus 1 over 75, that is a 75 plus 1 over 55, the inverse of that, plus 35, and that all equals, well, let me just find it, 91.73 ohms. Sorry, it just takes a bit of time. I was doing it in my head. Not really. Let's see. So, using that, we apply this value to our equation over there, I equals V over R, and we get I equals 12 over 91.73, and that tells us that the total current is 0.13 amps, and that would be part B. So, and that's number 4. Step 1, step 2, kind of, step 3, step 4. Step 5 would be just say like it's within the range or something. I don't know. As I said, make something up at this point, you know. Okay, so A is actually well, if you want to overcomplicate things like me, then obviously it will get pretty complicated. So what you do is you say, we use the properties of a series circuit. The amperage for the first resistor is equal to the amperage of the second resistor. And when I say that, when I mean, no, okay. So amperage of one resistor would be equal to the amperage of any other resistor on the circuit. Again, as I said, we treat it as if it's a simple circuit except when it's parallel. When it's parallel, we treat the parallel parts as if they're one resistor. So the amperage for these two, the total would be equal to this value here, and since these are parallel, their voltages are equal. So the voltage drop before and after will be, essentially we can find it from saying that V equals IR, and we can use this value as we know it applies for this whole thing, and we can use and then we'd find the resistance total using the properties of a parallel circuit's resistance. If that's all too complicated, just copy down exactly what I write and you'll be fine. For the test, there's like a crazy curve, so, uh, unless, you want a growth mindset, in which case, buy a physics textbook or something. So the total resistance for this part over here would be 1 over R2 plus 1 over R3, and we'd find the inverse of this to get the total resistance. So we'd find the inverse of that. I'll skip the step where I write the actual numbers, and I'm going to give you the answer, which is 31.73 ohms. But wait, now we have to plug that into, or substitute that into, our wonderful formula, and we will find our actual answer for part A. So V equals IR, right, equals 0.13, let's do that again, 0.13 times 31.73, or again, just to be pedantic, it's actually the squiggly line, and that equals, or that's also around 4.15 volts. And so that is part A. And that's our answer. For step 5, just again, say it's within the ballpark. So again, the voltage drop would be if you, and I just want to restate this so that it makes more sense. The voltage, okay, so for this series circuit, you'd have the total voltage equals the voltage of this part plus the voltage of that part plus the voltage of that part. So the voltage drop is how much the voltage drops before and after this part, and that would be the total voltage of that part, if that makes sense. So the drop is the same thing as the actual voltage here, and that's why this all, and it does say voltage drop around the 75 ohm resistor, but it's parallel, so we do both of these. So yeah, that's a basic explanation. It's kind of, this one was kind of complicated, and I don't know if I explained it too well, but I hope you can, you have a ballpark, understanding of how this works, at least, and that's the answer. I'd probably do it again if I had more time, but I don't, so sorry.